Domain and range. What are mathematical functions? A mathematical equation is a relationship between two values. One value is represented by x. This is called the independent variable. The second value is represented by y. This is called the dependent variable. Here is an example. The value of y depends on the value that is entered into the equation for x. For example, if x is equal to 4, then y would equate to y equals 3, substitute in 4 for x, plus 4, and solve. 12 plus 4 is 16. Sets of numbers. The numbers that we use to put into a function for x can be part of a set of numbers. There are different sets of numbers. Let's take a look. The natural numbers are the numbers that contain whole numbers, numbers that don't have fractions or integers, such as 1, 2, 3, 4, 5, etc. Integers are positive whole numbers, negative whole numbers, and 0. The real numbers are all the numbers that we can use. They're whole numbers, decimal numbers, could be expressed as fractions, and they have a continuous quantity. They go on for infinity. To express the set of numbers that will be used in a mathematical function, use the syntax, the set of x or y, such that x is an element of, and then write your number set. This is read as the set of x such that x is an element of a number set. If natural numbers are used, then the number set can be written as x is an element of n. If integers are used, x is an element of I. If real numbers are used, x is an element of r. When given a function, it can be graphed on an xy coordinate system. Here's an example of what it could look like. Infinity. The term infinity as a math term means endless. The lines can continue on indefinitely. No one knows where they end, or do they end? The symbol infinity is used to represent infinity. We can say that x approaches infinity or negative infinity, or y approaches infinity or negative infinity. Positive infinity for x, negative infinity for x. Positive infinity for y, negative infinity for y. Applying this to quadratic equations. Let's start with the example y equals x squared plus 6x plus 9. If we were to draw a graph of this, we can say that the graph opens up. How do we know? Because there's a plus sign in front of x squared. Next, we need to determine the vertex. How to do this? Write the equation in vertex form, x plus 3 squared. The vertex will be -3, 0. Now, let's apply this to quadratic equations. Let's determine the domain. The domain represents all the values that can be substituted into the equation for x. As this graph continues left and right, this would be negative infinity to the left and positive infinity to the right. We say the domain is the set of x such that x is an element of the real numbers, written as the set of x such that x is an element of the real numbers. Applying this to quadratic equations for the range. The range represents all the values that can be substituted into the equation for y. As the graph starts at the value 0 and continues upward, the range would be the set of y such that y is greater than or equal to 0, and y is an element of the real numbers. Read as the set of y such that y is greater or equal to 0 and y is an element of the real numbers. Now, let's summarize. Determine the set of numbers being used in the equation. Determine the vertex. Determine whether the graph opens up or down. State the domain and range. Write your solutions. Now, let's put this information to use.